Hi, I'm Brian, and this is Gemi-fly, an autonomous drone inspection powered by Gemini 3. Today, I will show you how Gemini gives drones the ability to see, understand, and act on their own. Here's the problem with drones today. They need expert pilots. Inspections are slow, mistakes happen, and in dangerous environments, humans are still in the loop. Automation exists, drones can avoid obstacles, follow waypoints, but they don't understand what they are seeing. Gemi-fly changes that. It runs on a DJI Tello, an education-grade drone with a single 720p camera, no LiDAR, no depth sensors. Using Gemini 3 Multimodal Vision, this simple drone can see and understand its environment, navigate autonomously, locate targets, and generate inspection reports. The intelligence is in the AI, not the hardware. Let me show you. Here's the drone autonomously finding and approaching a target. There is no pilot and there is no remote control. This is just Gemini making decision. Now let me show you the dashboard view. So here's the dashboard. You can run the main script and connect it to DJI Tello drone, or you can run the demo script where I already recorded two scenarios with two different input. So we'll try this one first, the blue bicycle rear cassette, and then press start. So here is the stream view of the drone, and we have the telemetry, the battery, the object detection, Gemini performance. So there is the first phase, the recognition. So it will scan 360 view of the environment, and then it will send those pictures to Gemini Flash. So now it will land because it will send the frames to Gemini Flash. So here Gemini Flash is analyzing the frame and it found that the target is on frame 4. We have a description of the target also. And now this frame is sent to Gemini Pro to calculate the position that the drone should be taking to face the target just after. It said that here he has to move at this place so that it faces the target. So it moves, and here it's facing the target. And now we are entering the approach phase where this is an iterative loop with Gemini Flash where we will send each frame each time it moves. So Flash is analyzing this first phase. Oh, and then we have a JSON where Gemini is locating the target. And so you will see this overlay, and that's really what Gemini sees. I'll skip those steps. Oh, and this is the last frame it took. And this last frame is sent to Gemini Pro for analysis and for generating the report. So here you can click on generate report and you have report of this flight. So we have the acquisition frame and the inspection frame, the last frame used. In the findings, you can see a great description of the frame. We see that there is some text, accumulated grime and oil, important information from that frame. And here the mission metadata. I've selected the smallest box on the table as input. I click start. I'll skip those phases, but it will do the same thing and it will find that the smallest box on the table is the green one, just here, the green rectangular cardboard. And then it will go into the iterative approach to go near this target. So here it took the last frame and sent it to Gemini Pro for analysis. And then we have the report. It recognized that it's a Puma shoebox, size, the number, the origin, here it is. So to recap, there is 5 phases. First, the drone will take off to do a 360 scan, and then those frames will be sent to Gemini Flash to find the target. Then Gemini Pro will analyze that frame to correctly position the drone at the beginning of the approach. And then there is the approach phase where Gemini Flash will analyze those frames until it reaches the target. And after that, we have the inspection with Gemini Pro. So this is why Gemini 3 is central to this project. We have two models working together. So Flash handles the approach loop, and we need a model which is fast. So Flash is perfect for that. And Pro handles the reasoning. so the spatial positioning and the detailed inspection. And both output structured JSON through a Pydantic schema. So this gives me a deterministic control. There is no hallucination movement, just reliable behavior. The applications are multiple: warehouse inventory, infrastructure inspection, search and rescue, anywhere inspection is dangerous, repetitive, or time critical. So that's Gemi-fly. The code is on GitHub. You can run the main script with a DJI Telo drone, and you can also run the demo script if you have no drone. Feel free to contact me if you have any question. Thanks for watching.